Geometric sequences. Well, geometric sequences are sequences, series of numbers, that you're multiplying by the same number every time. Like, let's say if I did maybe 2 times 6 times 6, and so forth. I think the next one would be 432. Yeah. And your ratio is 6. Or let's say if I did something like 40. Divide by 2, divide by 2, or in a sense, you're dividing by 2 or multiplying by half. You can even have a negative ratio. Let's say that you had this. Notice how you're multiplying not just by 3, but by negative 3. And so all that's nice, but let's say I gave you something like first term is 5, ratio is 2, and you're looking for the 7th term. Now, obviously, yes, I could multiply by 2 the answer, a total, and get the 7th term. But they came up with a formula for you to make it more exact, more concise, less guesswork. Nth term is last term equals first term. R is your ratio. And N, just like with arithmetic, is your number of term. So if you wanted to find the 7th term equals first term, which is 5, ratio is 2 to the 7 minus 1, or 6th power. So 5 times 64, 320. But they can give you a variety of variables, but let's say they give you a term in the middle and a term on the end and want you to find the first 3 terms. Let's say they give you the 5th term is 80, the 8th term is 640. Find the first 3 terms. Well, you know the last term is 640, but they don't give you the first term. But they do give you a term in the middle. So 80. The ratio you don't know, 5 minus 8. I'm sorry, 8 minus 5, 3. Divide by 80. 8 equals R cubed. R is 2. So if your ratio is 2, you can either literally divide out to go back to the first 3 terms or use the formula again. 80 equals, first term you don't know, 2 to the n minus 1, or 4th power. So 16a, divide by 16, first term, 5. So 5 times 2 times 2 times 2. And actually, that's the first 4. I gave you a freebie. Now, let's say the other type they could give you is still 2 in the middle, but there is a slight difference. Let's say that I give you the 24th term is, second term is 24. The 6th term, 1944. So you're going to do it the same. Last term equals earlier term, middle term, 24. R, which you don't know. And then 6 minus 2, 4. So when you divide by 24, you get R to the 4th equals 81. So R is 3, but there's one slight thing. Remember, if I have a square like R squared equals 9, when you take the square root, it is 3, but it's also negative 3. Well, that's going to happen here. It's 3 and negative 3, but it's really just going to be a slight difference. Now this one, since the second term is 24, notice how if you just divide by 3, you get 8. Multiply 3, you get 72. So there's really no need to plug in the formula. But you might be saying, okay, what about the negative 3? Well, if that's 24, if you divided by negative 3 and multiplied by negative 3, notice how every other term is going to be negative. So that's a little bit with geometric sequences. Remember again the formula. Last term equals, or term in reference equals, first term r to the n minus 1 power. I hope this was of help to you, and you have a great day. As normal, anything you need, more problems you want to see worked, let me know.